In episode 38, titled VPN Types, Site-to-Site versus Point-to-Site versus Remote Access, we treat virtual private network types as different trust and scale patterns because the right tunnel depends on whether you are connecting networks, devices, or people. The exam often presents these options as if they are interchangeable, but they solve different problems and carry different assumptions about identity, routing, and operational burden. A site-to-site tunnel makes two networks behave like they are adjacent in a controlled way, which is powerful for branches and hybrid integration, but risky if address planning and segmentation are sloppy. A point-to-site tunnel extends private access to an individual device, which is ideal for limited administrative or specialist access, but does not scale like branch connectivity. Remote access is primarily user-oriented, emphasizing identity, authentication, and session governance because it is about who is allowed in, not just what network they come from. When you can map the scenario to the right trust pattern, you can eliminate distractors quickly and choose the best answer with confidence. The goal of this episode is to make the three types feel like clean tools with predictable strengths and predictable failure modes. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Site-to-site virtual private networks connect networks with persistent encrypted tunnels, meaning the endpoints are usually gateways, and the purpose is to provide ongoing routed connectivity between address spaces. The site in site-to-site is a network boundary, such as a branch office, a data center edge, or a cloud virtual network, and the tunnel is typically always on so that services can communicate without users initiating individual sessions. Because the endpoints are gateways, site-to-site tunnels commonly carry many flows for many devices, and they often become a shared dependency for availability and performance. This model supports consistent routing and centralized policy because traffic crosses a known boundary where inspection and logging can be applied. The trade-off is that site-to-site connectivity expands the trust boundary, so you must treat it like a network integration event rather than a simple encryption feature. In exam scenarios, site-to-site tunnels appear when the prompt describes connecting branches, integrating on-premises with cloud, or enabling shared access to internal services across locations. The key is that site-to-site is about network reachability, and reachability must be controlled with segmentation and route hygiene. Point-to-site virtual private networks connect individual devices into a private network, and the purpose is typically limited access for a specific endpoint rather than permanent network integration. In this model, a client device runs a tunnel endpoint, connects to a gateway, and receives an address or a route set that allows it to reach internal resources. Point-to-site is often used for administrators, contractors, or specialized devices that need private access without connecting an entire remote network. It is also useful when a site-to-site tunnel is not justified or feasible, such as when the remote party is a single laptop rather than a full branch network. The operational reality is that point-to-site requires client configuration, distribution of credentials or certificates, and support for devices that connect from many networks, which is different from the gateway-managed nature of site-to-site. In exam scenarios, point-to-site shows up when the prompt mentions one device needs access, administrative access from home, or limited specialist access, rather than a whole office needing connectivity. The key is that point-to-site scales by client count and management, not by routing simplicity, and it is best when access needs are narrow and well-defined. Remote access is user-oriented connectivity with identity enforcement, meaning the central question is who the user is, what they are allowed to access, and under what conditions they are permitted to connect. Remote access may use a tunnel, but the defining property is the authentication and authorization model, which often includes multi-factor authentication, device posture checks, and group-based policy. This model aligns with modern realities because users connect from many networks and devices, and network location is not a reliable security boundary. Remote access also emphasizes session governance, such as timeouts, logging, and conditional access, because user sessions can be abused if credentials are stolen. The practical design goal is to provide secure access while limiting blast radius, which often means providing access to specific applications or specific segments rather than granting broad network reach. In exam scenarios, remote access appears when the prompt emphasizes users working remotely, identity requirements, compliance, or the need to enforce strong authentication and auditing. The key is that remote access is primarily an identity problem delivered over a network path, and treating it as only a routing problem often leads to weak designs. A strong default is to select site-to-site for branch connectivity and hybrid integration because connecting networks is exactly what it is designed to do when the remote endpoint is a gateway and the connectivity must be persistent. Branch sites often need consistent access to internal applications, centralized services, and shared resources, and a site-to-site tunnel provides a stable, routed path that does not depend on individual user sessions. Hybrid integration between a data center and cloud networks also fits, because the goal is to connect address spaces so workloads can communicate reliably during migration, replication, or steady-state hybrid operation. In these scenarios, routing and segmentation become central because you must define which subnets are reachable across the tunnel and which are not. Monitoring also matters because site-to-site tunnels can carry a large portion of business traffic, and failures can be broad when the tunnel goes down. In exam reasoning, when the scenario includes multiple devices at a location needing access, site-to-site is usually the best answer because it matches the scale pattern. The key is to treat the tunnel as infrastructure with redundancy and clear policy rather than as a one-off connection. Point-to-site is a strong choice for administrators and limited device access because it provides targeted private reachability without integrating entire networks and without requiring a branch gateway. Administrators often need access to management interfaces, jump hosts, or diagnostic tools, and point-to-site can provide that access on demand while keeping exposure limited. This model also supports temporary access for contractors or incident responders because you can grant and revoke access at the user or device level rather than maintaining permanent network integration. The design should still enforce strong identity controls because administrative access is high impact and credentials are a common attack path. Point-to-site also allows you to avoid building full site connectivity when the remote need is narrow, which reduces the blast radius if the client device is compromised. In exam scenarios, when the requirement is a few admins need access, or a single device must connect securely, point-to-site is often the best fit. The key is that point-to-site is about scoped access for a device, not about full network adjacency. Authentication options matter across all types, and the exam often tests that identity matters more than Internet protocol alone, because addresses are weak identifiers in modern environments. Gateways can authenticate each other using shared keys or certificates for site-to-site tunnels, but user identity and device identity become critical when humans initiate access or when devices are not fully controlled. Remote access designs often require multi-factor authentication, certificate-based device trust, and group-based authorization, because stolen passwords are common and because least privilege requires fine-grained policy. Even in site-to-site, you should still think about who and what is allowed across the tunnel, because the tunnel itself is not a permission model, it is a transport. This is why many designs include additional controls like security groups, firewall rules, and application layer authentication on top of the tunnel. In exam scenarios, when the prompt emphasizes security and compliance, answers that treat the tunnel as the only control are usually incomplete. The best answer is typically the one that pairs connectivity with strong identity and authorization controls, because trust should be defined by identity and policy, not by address adjacency. Split tunnel versus full tunnel is another frequent exam pivot because it affects both security and performance by deciding what traffic is forced through the tunnel. Full tunnel routes all client traffic through the virtual private network, which can centralize inspection and policy enforcement, but can increase latency and load by hairpinning internet traffic through a central point. Split tunnel routes only specific traffic through the tunnel, while allowing other traffic to go directly to the internet, which can improve performance and reduce central bandwidth use, but can reduce visibility and create a risk that unmanaged internet paths bypass security controls. The best choice depends on the scenario's priorities, such as whether the organization requires strict inspection of all user traffic or whether performance and user experience are dominant concerns. Split tunneling can be safe when combined with strong endpoint security and clear policy, but it must be designed intentionally because it changes the threat model. In exam scenarios, when the prompt mentions limited bandwidth, cloud-first applications, or user experience problems, split tunneling is often favored, while highly regulated environments may favor full tunneling for centralized control. The key is to treat split versus full as a policy decision about control points, not as a performance tweak alone. A simple scenario is connecting two offices to share applications securely, because it highlights the site-to-site model and its assumptions. If both offices have many users and devices that need consistent access to shared services, a persistent gateway-to-gateway tunnel provides stable connectivity without requiring each user to manage a client tunnel. Routing must be planned so that each office can reach the required subnets at the other office, and return paths must be correct to avoid one-way failures. Security policy should limit which networks are reachable across the tunnel, because a tunnel is not a reason to make everything flat. Monitoring should track tunnel health and latency so users do not discover failures first, and redundancy should be considered if the business requires continuity during link outages. In exam reasoning, site-to-site is typically the best fit here, because the requirement is network-to-network connectivity, not user-by-user access. The key is to treat the tunnel as a controlled bridge between two trust zones, governed by routing and policy, not as a blanket union of two networks. Overlapping private ranges are a classic pitfall that breaks routing across tunnels, because the same address cannot reliably refer to two different places in a routed environment. If both sites use the same private network range, traffic destined for that range becomes ambiguous, and routing decisions can send packets to the wrong site or drop them entirely. This can manifest as some services being unreachable, traffic arriving at the wrong destination, or confusing behavior where local access works but remote access fails. Workarounds like translation exist, but they add complexity and can complicate logging and policy enforcement, which is why the best answer in many scenarios is to avoid overlap through careful address planning. In exam scenarios, if the prompt mentions a merger, rapid expansion, or both sites use the same private range, overlap is often the hidden constraint that explains connectivity failure. The correct answer often involves readdressing or planning unique ranges, because clean routing requires uniqueness. Recognizing overlap as a hard constraint helps you avoid tunnel designs that are theoretically correct but practically broken. Weak multi-factor authentication is another pitfall, because credential-based entry is one of the most common ways attackers gain remote access, and a tunnel without strong user authentication becomes an easy path inside. Remote access environments are particularly exposed to credential stuffing, phishing, and password reuse attacks, and tunnels can amplify the impact because once inside, the attacker may have broad network reach. Multi-factor authentication reduces this risk by requiring an additional factor beyond a password, and it is often expected in exam scenarios where remote access is discussed. Weak authentication can also mean weak device posture checks or insufficient logging and alerting, which makes abuse harder to detect. In exam reasoning, when the prompt emphasizes secure remote connectivity, the best answer usually includes strong identity enforcement and multi-factor authentication rather than focusing only on encryption. Encryption protects the transport, but identity protects the decision of who gets access, and identity is often the greater risk. The key is that remote access security is primarily identity-driven, and tunnels must be paired with strong authentication to be safe. A simple memory anchor is networks, devices, users mapped to VPN types because it helps you choose quickly under exam pressure. Networks map to site because you are connecting address spaces and routing domains through persistent gateway tunnels. Devices map to point to site because a specific endpoint device needs private reachability without connecting an entire site. Users map to remote access because the design emphasis is identity enforcement, session governance, and least privilege access based on who is connecting. This anchor is not meant to remove nuance, but it gives you a correct first approximation that you can refine based on constraints like scale, compliance, and performance. It also helps you avoid choosing point to site for an entire branch, which would create a management nightmare, or choosing site to site for a single admin laptop, which would be nonsensical. In exam scenarios, the best answer often comes from making this mapping and then accounting for identity and routing constraints. When you can recite the anchor, you are less likely to be tricked by answers that use the word VPN without specifying the trust pattern. To end the core, choose a virtual private network type and list key assumptions, because the exam often tests whether you notice the assumptions hidden in the option you select. If you choose site to site, your assumptions include unique address ranges, correct routing in both directions, and clear policy about which subnets are reachable across the tunnel. If you choose point to site, your assumptions include client management, strong user or device authentication, and scoped access that limits blast radius if the endpoint is compromised. If you choose remote access, your assumptions include identity enforcement such as multi-factor authentication, session logging, and a clear decision about split versus full tunneling based on security and performance needs. In all cases, you assume encryption is present, but you do not assume encryption alone is sufficient, because authorization and segmentation still matter. You also assume monitoring exists, so tunnel failures and unusual access attempts are detected quickly. The best exam answer is usually the one that fits the scenario and whose assumptions match the environment described, rather than the one that requires hidden heroic conditions. When you make assumptions explicit, you make your reasoning more accurate. In the conclusion of episode 38, titled VPN Types, Site-to-Site versus Point-to-Site versus Remote Access, the core patterns are that site-to-site connects networks persistently, Point-to-site connects individual devices into a private network, and remote access connects users with identity enforcement and session governance. You select site-to-site for branch connectivity and hybrid integration, and you select point-to-site for administrators and limited device access when full site integration is not needed. Authentication and identity matter more than Internet protocol alone, and split versus full tunneling is a deliberate trade-off between centralized control and performance. You avoid pitfalls like overlapping private ranges that break routing across tunnels and weak multi-factor authentication that enables credential-based entry. You use the anchor networks, devices, users to map requirements to the correct tunnel pattern quickly. Assign yourself one tunnel selection drill by taking a single remote access requirement and stating which type fits, what assumptions must be true for it to work safely, and what control would reduce the biggest risk, because that drill is the decision-making skill the exam is measuring. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.